On to the next session. I'm not actually even sure exactly what I'm allowed to say about what's about to happen. Formerly, you may have heard of models like something called Llama. I don't know if anyone's heard of Llama, but somebody was responsible for making it safe. And then apparently he has even better ideas to do with his life now. And so I actually am not sure what we're going to learn about here, but at least somewhere between the two of those. So this is Josh, and he does really cool stuff.
All right, thanks, Leo. I'm tall. I don't know. Here, one second. Can you guys hear me? Okay, like this? Okay. Okay, so I'm Josh. It's nice to meet everybody. So yeah, like Leo said, up until 3 or 4 weeks ago, I was engineering lead for AI security at Meta. So I built the AI security program. So our program around applying AI to all the problems in the CISO org at Meta. And I also worked on, sort of built and incubated the Llama security effort and our prompt injection guardrails effort. But yeah, now I'm at a startup with my friends Gabe and Hiram, who I think are both here. And we're building AI agents for defensive security. So I'm going to talk about, so basically this talk is my framing of what it looks like to build well-engineered, like scientifically based agents for security. And I think I have 20 minutes if I'm going to leave 5 minutes for questions. So I'm going to look at the clock while I talk. Okay. So we think that so the company I'm at is Security Superintelligence Labs. It's just Gabe, Hiram, and myself right now. So when I say we, that's who I'm talking about. We think that we're going to have to pretty soon get into sort of dangerous territory with AI agents that we're building for security defense. Dangerous in the sense that we're going to need our agents to, without our looking at them and watching them, make dangerous state changes to our infrastructure and to our code bases. Yeah, so this is going to mean getting comfortable with agents doing sort of milquetoast level things like investigating SOC alerts. But it also is going to mean having agents do much more serious things, like turning off your executive's computer when we think it's compromised, or patching a production code base, or shutting down a host that we think is compromised. Because we're dealing with like opaque neural networks, and because mechanistic interpretability is nowhere near the level that we need to verify these neural networks, really the only game in town for verifying that the agents will do what we need them to do when it counts is statistical evaluation. So just lots and lots of behavioral evaluation to see what they do under lots and lots of different circumstances. So this isn't so different than like the self-driving problem, for example. And I think this applies to like every area of cyber autonomy that we're gonna have to build for, right? So autonomous code remediation, alert management, access control, cloud posture management, lots and lots of different, really all the subdomains in security in which we're making changes. Okay, so here's the security model that we were using. Well, I'm sure my old team is still using at Meta, in which we're using at the startup. Basically, so there's various levels of maturity that you can inhabit when you're building agents for security. So the first state that I call the crawl state is when it's just all vibes, right? So you're building an agent and you're asking the agent to say classify documents as to whether they're sensitive or not, or follow up on a SOC alert and dismiss it as a false positive or not. The sort of level of rigor is just, it works on my machine on a handful of examples. So I think much of the industry is in this crawl state right now. And then, the problem with crawl, which I think surprises people who don't come from a machine learning background, is that you quickly get into this pathological state in which people just, are making claims about how well their agents are doing on their cherry-picked examples. But you can't make progress as a team or even as an individual. And there's really no basis for saying that like version 1.2 of your product is better than version, the previous version. Okay, so then there's this walk state that we talk about. So walk is like, maybe you're not making full use of the data that you have access to, but you do have some evals, right? That are good enough that they are uncontroversial within your team and organization. Uncontroversial with respect to their indexing of the problem that you're trying to solve. So if that's patching a code base, right? Maybe you've agreed that a bunch of open source projects in your eval sets that that pass their unit tests, that constitutes a pass in terms of producing a patch. And every night, your team runs their candidate agents against these evals. And when somebody claims to be on the top of the leaderboard, this doesn't cause a big philosophical debate. But everybody can agree that, okay, like you actually have the state-of-the-art agent, and that becomes a candidate to actually ship. Okay, and then there's, oh, right, okay. But I think there's a limitation to this walk state, which is that we're still at this point, not taking advantage of, we're still at this point just using sort of vanilla off-the-shelf LLMs. And this point might be controversial in this group, I'm not sure, but I think there's a limit. If our ultimate goal is actual autonomy, making autonomous state changes to our code and our infrastructure, I think we're eventually going to need to build fine-tuned models that are specialized in making those decisions. Just to this final state, which I call run. And this is sort of I think this is the mature state in which any actually machine learning product is operated, in which we are building models based on, we have a sort of inner loop in which we're improving our agents based on offline evals. So those evals that we've all agreed sort of index the problem that we're solving. But then we have a sort of outer loop in which we're deploying the agents in A/B tests and evaluating how well they do on our online metrics. And we're even fine-tuning those agents based on that feedback. So we see people adopting this motion outside of security. So for example, it's pretty clear that Anthropic has adopted that motion with respect to fine-tuning their models for coding based on all the customer feedback they're getting from people using their models. It's pretty clear at places like Meta and Google, people are doing that based on more sort of consumer use cases. We're eventually going to need to do that in security, but very few people are doing that yet. Let me check time. Leo, what time should I stop talking? Is there like, okay, I'll just keep, okay, all right. I think I've probably gone for like 10 minutes. Okay, and so it's really urgent that we get to this run state, right? So I think in security, it might sound like I'm stretching a bit, the idea that we would get to this run state, since the state of affairs with respect to the evals that we have with respect to fine-tuning models for specialized security use cases is immature. But people have done this in other industries, right? So there's really mature areas like ads, ad recommendation, right? Or feed ranking, like at a company like Meta, or search when it comes to Google, in which this sort of run state is just the accepted standard with which we run ML products. We need to get there within security because the attackers are coming with automation, and the offense is way easier, I think, in this new AI era than defense, just as it was before. It's way easier, for example, to build an agent that that does a React loop and breaks into your network than it is to defend the network. I think adversary behavior over the next year or two is going to be a forcing function to sort of achieve this level of maturity. Okay, so here's some bad news with respect to our ability to achieve this level of maturity. Basically, I think that noise is built into the technical problem that we're facing here. I think our whole model for how we do evals in machine learning is based on the sort of benign world of like text and image classification going back decades. So in computer vision, right, the famous ImageNet data set, which was put together in the 2010s and that sort of drove a lot of the convolutional neural network progress in that decade, was based on labeling images, in terms of like, a taxonomy of categories. I think there were hundreds of categories actually in ImageNet. And this is a totally different ontological environment, right? So labeling a cat versus dog, an image as a cat versus dog, is like totally different epistemologically than understanding, for example, where all the bugs are in the Linux kernel. So it's actually unknowable from a theoretical computer science perspective, right? Where all the bugs are in the Linux kernel, right? So you couldn't go and label all that data. Deciding whether a binary is malware or not, there's all sorts of theoretical problems with that. When you go and ask people to start labeling security data that has these very difficult epistemological problems built in, you run into all sorts of problems. So we actually did this at Meta, right? We got committees of analysts to label data. So for example, if you go try to get SOC analysts to label an alert as sort of worth investigating or not worth investigating, they'll often disagree. Actually, what I've found in my experience is that there's like a double-digit disagreement rate between any two analysts, right? So it's actually very hard to get clean labels, and that imposes a noise ceiling on your ability to improve your ML system, right? So once your ML system gets 90% agreement rate with your analysts who disagree 10% of the time, right? You're sort of in this region in which you can't actually further improve. I'm going to skip over some slides just to go fast. Here's a simulation I ran, sort of demonstrating that dynamic. And so this uncertainty is just a built-in feature of the security landscape. So in almost every domain in which we operate in security, we're dealing with a pretty low noise ceiling. That's for sort of theoretical computer science reasons. That's also because adversaries are attempting to hide from us, right? So we don't have access to the most recent malware examples that are actually active in the wild, right? We also don't have access to the 0 days that the NSA is working with or the Iranian government is working with, right? So this is always going to be a dynamic in our field. Okay, so I think the good news is that we can sort of reframe a bit in order to allow ourselves to hill climb even further beyond this kind of noise ceiling. Okay, okay. So thanks for whoever laughed. Thanks for appreciating my my AI art. Okay, so in traditional machine learning, there's the construct of an oracle, right? What one is supposed to imagine when using ImageNet is that it wasn't mechanical Turkers, right, who labeled the data set. It was an oracle, right? And the oracle knows the true label of every image, right? And sort of comes down from the Platonic heaven and bestows the label cat upon an image, right? And then we can trust that label as ground truth. The oracle just doesn't, so that was an okay conceit to make in classical ML. It's not an okay conceit if we're going to climb the hill up to full autonomy within cyber defense, right? We need some other construct that allows us to continue to hill climb. So here's sort of like how ridiculous it is to evaluate an agent using classical machine learning, right? So in classical machine learning, if you're using metrics like precision, recall, and F-score, right? The way you're modeling your agent's outputs is as just a sort of binary vector of like, yes, this is malware. No, that's not malware, right? And so you're actually taking like, let's say you're using a coding agent to identify vulnerabilities in a program. You're taking like a bajillion tokens that came from like a trillion dot products, right? And you're reducing that entire output to like this one, right? And then you're comparing it to a label, which you're actually quite uncertain about, which is this one here, right? And then you're doing some math on these binary vectors to get your final summary statistics. This is like a really sad, like woefully impoverished representation of your system, right? You want to do much better than that, right? Okay. So these are maybe okay assumptions for like a traditional classification problem, like a document classification problem, but these are really bad assumptions when you're reasoning under the kind of uncertainty that we're dealing with in security. So here's my thesis about how we need to sort of reframe the evaluation problem as we build towards AI agent autonomy. So we should use those traditional accuracy metrics because we don't want to, because those are, we don't want to throw out signal. We also want to actually look at the agent's reasoning and behavior and understand and sort of look at the agent as we would an employee we were evaluating as a security engineer, right? To understand, is it collecting the right evidence? Is it reasoning from first principles? Is it justifying its decisions correctly? Because there's a lot of signal in the reasoning traces themselves. Okay. So here's the kind of evaluation that we need, and this is the kind of evaluation that you do within an interview, I think, within a kind of behavioral interview of a SOC analyst or a security engineer. We want to know how high quality is the agent's reasoning under complex and ambiguous circumstances in which uncertainty is built into the environment. Did the agent come to the same conclusions as our best security engineers in the last 10 incidents? But if not, was it actually right against the engineers? This is something I actually found many times in practice, as the agents actually disagreed correctly with a committee of analysts. Does the agent retrieve the right context and call the right tools in an intelligent way that we can relate to and that is reasonable versus going completely off the rails, right? And then we also want to ask what the agent's precision and recall were, but in the context of this much larger picture in which we're taking advantage of all the signal in the agent's behavior. Okay, it looks like I have 5 more minutes. Okay. Okay, so the way we were pursuing this at Meta and the way that we're pursuing this at Security Superintelligence Labs is we follow a procedure like the following. So we define a rubric for what good job performance is with respect to the agent's observed behavior. We have humans grade the trajectories based on a protocol that we design. And then because that doesn't scale to the hundreds or thousands or tens of thousands of agent runs that we actually do, we calibrate a judge LLM to those human judgments, and then we sort of use that judge LLM offline and online to actually understand the agent's performance. Okay, I'm going to skip through the worked example because I'm almost out of time. But okay, so I mean another thing I'll say here is that once you have an evaluation methodology like that in hand, once you have a calibrated judge LLM, then you can actually automatically hill climb, right? So you can hill climb the design of your agent harness and your prompts, and you can also hill climb in parameter space. Okay. So yeah, last I just want to say a few practical notes on process that these are just some lessons that I've learned over the last year or two, and actually working on designing AI agents for security. First of all, if you're building agents in your organization and you don't have evals, building evals is an iterative process. You don't have to do it perfectly at first. We iterated many, many times on our evals at Meta when I was doing that work at Meta, and that's what we're starting to see in our startup as well. You really need to budget a copious amount of time to evaluation. I would say at least 50% of one's time needs to go to evaluation in machine learning. And actually the big breakthroughs of the last 15 years in machine learning, I mean, actually really the last 30, 40 years, right, have all come from evaluations, right? So the MNIST data set, if people are old enough to remember that, right? The SWE-bench data set, which is now, well, I think at this point it's been saturated, but it's an index of AI coding agent performance. ImageNet, which was really the driving force behind the development of convolutional neural nets. We're going to do the same thing in security, and on any given team, right? Any time spent on evaluation isn't wasted because it allows you to actually index your own progress and actually iterate and improve. Okay, I'm done. Hopefully that was useful. Thanks, and would love questions and discussion.
Yeah, any questions for Josh? I have one, I guess more, maybe you say, hey, look at slide 7 for this one. Feel free to but I think there's like a fundamental leap being made here, or assumption that I was curious what the grounding on, which is, well, you could imagine a textual gradient on improving the harness versus doing a regular gradient on improving the transformer, right? And so I believe evals, and I think that's the way forward, but I think there's this question of if you told me that improving the model will give us more efficiency, so I could run a smaller model at better performance per watt or tokens per watt, I would have believed you. But the leap that I'm not directly seeing is that there's we need it for quality of result. I'm wondering if you have any intuition of why we can't do textual gradients essentially, in prompt engineering, context engineering to are we at a point where the base reasoning models are improving enough and getting enough that we could just do the harnesses? Where for the quality, not performance, do we really need the better?
Yeah. So Leo, is basically what you're pushing on is why do we need, or maybe at what point do we need specialized fine-tuned models and security versus why can't we just elicit the behaviors that we want by optimizing in prompts?
Yeah, can't we just keep writing OpenAI and Anthropic? Where does that change from not a performance side but a quality side?
Yeah. I mean, okay, so I think you wouldn't disagree that probably okay, take a problem like data loss prevention or something like that. I imagine you wouldn't disagree that it's highly unlikely that the logical end, many people right now are using Sonnet 4.6 to decide whether documents going out in email attachments are sensitive corporate IP, right? And I think you wouldn't disagree that that's probably not the logical end state to have a 1 trillion parameter model doing that job, right? So I think at a certain point we're gonna, as we mature as an industry, we're probably gonna swap out these huge generalist models for more specialist models.
So in that one,
yeah.
if I was gonna,
yeah.
what I would say is well, more important is to have the digital twin, so we have the context of the user, the organization, the document, and then as models keep shrinking, I'm not actually sure we need a generalized model. I would actually expect we could use even a dumber and smaller model.
So basically, the argument would be what you're gonna want is a small sort of generalist cognitive core that does RAG, or you give it the right context and it can make generalized decisions. Yeah, I mean, it's possible, right? I think it's an empirical question. I guess my hunch is that, if you look at what, I think that, if you look at what Anthropic and Cursor are doing, they have a flywheel with respect to customers using those models for coding, and they're sort of hill climbing that specific capability. And the knowledge is being baked into the parameters, right? Like that, you know what I'm talking. Chris just like Composer 2 or whatever. It's this new fine-tuned model. So I think we'd have to, and I think that's what I think that's what Meta and Google and OpenAI are doing with respect to consumer chat use cases also, like the behaviors that they're getting out of those models, like the sequences of like reasoning and tool calling they get to answer questions like find me the best restaurant in San Francisco, and like after Leo's event, right? This kind of thing. I think that's being fine-tuned into the parameter space also. So yeah, I think I'm skeptical that, so it's possible it will go in the direction of some sort of general reasoning core that's, augmented by RAG, but that doesn't seem to be the direction we're going right now.
I guess I could make that claim for the performance side. I know, and the speed side, I would totally do it. But so the question is really, the hard part for me is the quality that, But anyway, but yeah, I feel like I'm monopolizing the floor.
Yeah. I just want to say, but I think you're getting at a good question. That like one last thing I'll say is like, the performance concerns, performance, throughput, latency, especially performance and throughput, but I think latency also eventually, I think these are like key design dimensions, like these are key product feature dimensions in security. Like in security, we probably want to get to a place where like 2% of the process tree deltas on all of your network are being reasoned about by an LLM. That would be a nice state to be in, right? And like, but to get there, we probably need 500 million parameter models, right, that are doing the heavy lifting there, or something like that. Anyways, that's all. This is where my intuition comes from around like the need for custom models.
We should talk more after.
Okay. Yeah.
I don't know for anyone else. There's it's really, we're lucky to have Josh and team here. So if you want to ask annoying questions like this.
I can always ask. Yeah, I guess I don't know where y'all are at as far as going to market. So I'm just curious from a customer point of view, what is it like to bring these capabilities into the sales processes, et cetera?
Yeah. We've only quit our jobs like 3 weeks ago, so we have so we don't have any customers yet. But yeah, maybe next year if we get invited back, we'll have a good answer.
Okay.
Okay, cool.
So yeah, maybe time for one more, but Diana will be setting up. So otherwise, thank you.
Thanks.
I have like so many questions.
Okay, yeah, let's talk about it.
You're sharing the screen already. But
Yeah, excellent.
let me double check. Yeah. Actually, let me make sure. So you're good.
Yep.
Okay. So yeah.